You're watching the lesson video of 1.8 real life applications, and that should actually say day 2, because you already did the first day yesterday, or the last video, and day 2 is actually going to be 2 different types of word problems: consecutive, integer, and coin. Okay, so just like yesterday, or just like last video, you probably recognized that making sure that you're organized and that you're defining variables are just very, 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 very important when it comes to word problems or solving word problems algebraically. So that's exactly what we did in number 1. So Ahmed has $4.15 in quarters, dimes, and nickels. So already I'm realizing that this is a coin problem because it's talking to me about all these coins. That's why setting up a chart is huge, because when we're setting up charts, we can stay very organized, including the value of the coin, and then we can even write an expression. So when I would set this up, I would make my chart, I would write in dimes, nickels, and quarters, the value: dimes are 10 cents, nickels are 5 cents, quarters are 25 cents. Then I need to put the expression. So he has 4 times as many dimes as nickels. So that means we have 4x. That's where the 4x comes from for dimes. Well, if dimes is 4x, what's just plain old x? Well, that happens to be the nickels. Okay? Something always has to just be x. Okay, so then there's 3 fewer quarters than nickels. 3 fewer quarters than nickels. That means I'm going to start with the nickels and take away 3. Then you put it all together, and what do you get? Well, we're going to multiply the value times the expression, right? If I had 3 quarters, I wouldn't say I had $3. What I would do is I would multiply 25 cents times 3 to get the 75 cents. Okay, well, that was just not even relating to this question, but that's what we're going to do here. We're going to take the number of dimes and multiply it by the value of the dimes and multiply it by the number of the dimes. In this case, it's an expression 4x. That's that part. Same thing with nickels. 5 cents times x, that'll give me the total value of all of the nickels. And the same thing with the quarters. 25 cents times the quantity of quarters, which will give me the total value of all the quarters. And we know that there's $4.15 total, so that's why it equals $4.15. Okay, let's try number 2 on our own. So Nate is paying a bill of $2.70 with quarters, dimes, and pennies. All right, let's set up our chart. Okay, so here's my chart. I'm labeling it as the coin, and I wrote in quarters, dimes, and pennies. Okay, so we're always going to do this. We're always going to be mindful of what coins we have. Okay, and we know that quarters are worth 25 cents. Dimes are 10 cents, and pennies are just 1 cent, 0.01. All right, that's the easy part. And not that this is more difficult, but you just have to think about it a little bit more. Okay, so here we have to come up with our expression, or however many coins there are. All right, let's see. What does it say in this problem? It says he has 5 less quarters than dimes. Okay, so we start with the dimes, x, and we take away 5 from that, we get our quarters. Okay, and then keep reading on. 1 more penny than dimes. Okay, so compared to our dimes, which is x, 1 more penny. So you got it. We're going to add 1 on. Next, we need to write an equation that can be used to find how to pay the bill. Well, we know that there's a total of how much money? $2.70. Yes, that's right. So something has to equal $2.70. We're going to do the same thing that we did with the first example. So 25 cents times the expression, and then we're going to add that to the number of dimes multiplied by the value of dimes. So 10 cents times x. So you see how we're just putting these 2 columns together? So like this becomes that, these become this, and these together become that. What am I using to keep everything grouped together nicely? Yes, you got it. We're not going to forget those parentheses around those expressions. And there you have our equation. Okay, moving on to solving algebraically. Okay, so question number 3, it gives us a lot of information that there's 26 coins in Connor's piggy bank and quarters and $1 coins. How many of each coin does he have if they total $14? Well, this one's a little weird because it doesn't tell you he has 4 more quarters and nickels or something like that. It says he has 26 coins total. So this is where you get to pick. Remember what I said, something is always X. I'm going to let quarters be X. And if I have X quarters or 5 quarters, in order to figure out my $1 coins, just take that number away from 26. So if I have 26 coins total, 5 of them are used up with quarters. 26 minus 5 would end up with, yes, we would end up with just 21 $1 coins. So we're just taking away the amount of quarters from the $1 coins. Setting up the equation the exact same way. I'll spare you all the details with the solving, so that way you can look. We get x equals 16. So this is what I was talking about before to figure out how many $1 coins. 26 minus 16 is 10. 16 plus 10 should be 26. It is. We're happy. Why did that go away? Oh, it doesn't like me. Oh well. All right. Oh, there it is. Oh, something's happening here. It's getting angry. All right, we'll erase those. Okay, let's look at question number 4. So Manuel has $60 in $5 bills and $10 bills. If he has 4 times as many $5 bills as $10 bills, how many of each bill does he have? Okay, I want you to take a minute now. You've seen 3 questions already with the setup. Try to set this little chart up. Pause the video. All right, here she is. So we're looking at bills instead of coins. And obviously the values, this was pretty straightforward in this one, which I liked. The only thing that you might have gotten backwards here is that it says he has 4 times as many $5 bills as $10 bills. So he has more $5 bills. That's why we're doing 4x and making the $10 bills just x. Okay, try setting up your equation. How does yours look? Hopefully like mine. I guess you probably could have put parentheses around this x if you wanted to also, because I did tell you parentheses are important. Okay, cool. Pause that video again. Solve it. All right, let's see how this looks. So I solved it. I found out that x is equal to 2, which means that there are 2 $10 bills. And then 4x, so 4 times 2 is 8, and there would be 8 $5 bills for a total of 60 bucks. All right, let's move on to the different type of word problem. All right, so the vocabulary word of consecutive means one right after another. So we're doing some consecutive integer word problems. Consecutive means one right after another. So consecutive integers, well, that would just mean integers that are one right after another. Integers, positive and negative whole numbers, one right after another. So like if we started at 7, 8, 9, 10, and so on and so forth. If we represented them using algebra, we would say x is the first one. How would I get from 7 to 8? Yeah, you add 1, so x plus 1. And then from 7 to 9, we would actually add 1, 2, and so on and so forth. So x plus 1, x plus 2, x plus 3. We're just adding 1 every single time. Consecutive even integers, on the other hand, we have to start with an even number. So like 2, 4, 6, 8. Who do we appreciate? Okay, so all of those. Again, something always has to be x. So we're always going to start with x. So x, first one. How do we get from 2 to 4? We don't add 1. We actually added, yes, 2. And then we're going to add another 2 on, so it's not going to be x plus 2 again. It's going to be x plus 4, and so on and so forth. All right, last piece. Consecutive odd integers. Odd. One right after another, consecutive odd. 1, 3, 5, 7, so on and so forth. Okay, the first one's always x. So if x is 1, how are we going to get to the next one? We're going to add, how many do we add? Oh, that's weird. 1 plus 2 gives us 3. We are adding 2. We're counting by 2 still. So x plus 2. That's funny. Even though it's odd, we're still going to add 2 every time. But that makes sense because we're counting every other. So we are adding 2. How do we get from 3 to 5? Add 2 again for a total of 4, and so on and so forth. Okay, I am going to leave the example for you to look at, the worked through example 5. Let's do one together. So number 6, it says find 3 consecutive even integers such that the sum of the first and the second is 26 less than the 3 times the third. Okay, so 3 consecutive integers. Oh, 3 consecutive even integers. We know this. So the first one always has to be, yes, x. What would the next one be if they're even? X plus, yes, we can look up here too. X plus 2, nice work. And then what would be the third one? X plus, not 2 again, that's not possible. 4, excellent. Okay, and of course we need to be thorough, so let's label. You might want to pause the video if you need a minute to write vigorously, because I took a minute to write all that stuff down. So the first consecutive even integer, second consecutive even integer, and third consecutive even integer. Okay, now reading on in the word problem, it says such that. All right, such that means, all right, we're transitioning into the equation. So the sum, we're adding the first and the second. So the first plus the second is equals 26 less than 3 times the third. So we're taking 26 away from 3 times the third integer. Okay, well, we can't leave first, second, and third, so we're just going to replace. So the first integer is x, plus the second integer is, yep, x plus 2. We could use parentheses. We don't necessarily need it with adding, but we definitely need it with 3 times the third, which is x plus 4 minus 26. And there you have it. There is the equation that they were looking for. Question number 6. Need another example? Check out question 5. All right, last question. Looks like we have to solve this algebraically according to up top here. 7 is a worked out example. Check it out if you need to. All right, Victor, he's weighing his dog Ollie and his friend's dog Kevin. Yay! The weights of the 2 dogs are consecutive integers of one another. Okay, so, I guess there's a little bit of information that's missing here. We don't know which dog weighs more. So, I don't know. This is a bad question, but let's assume that X is Ollie's weight. So Ollie's going to be the lighter one. And then Kevin, let's put Kevin's weight next. And what does it say? Are they consecutive integers? Are they consecutive even? They're just plain old consecutive, one right after another. So x plus uno, x plus 1. Okay, if the sum of their weights, so we're adding their weights, and that is going to equal 119 pounds. This is easy. So we're going to do Ollie plus Kevin, and that's going to have to equal 119. So x plus 1 equals 119. All right, solve it. All right, here's my solve. I got x is equal to 59. See how I use Christmas colors? Is it Christmas yet? So I solved it, ended up getting x equals 59. So we know that Ollie, he's 59 pounds, right? It is pounds, yes? Yes, pounds. And then Kevin is just a pound heavier, 60 pounds. And there you have it. We are finished with this question, even though it was kind of a bad one. It should have said somewhere in here, Ollie's the lighter dog, or Kevin's the chubbier one, which is really, he's not chubby. He's only a pound more. So that's a wrap, folks. Hope you enjoyed the video.